Ladies and gentlemen, welcome after the last break with Marek. We shall continue the last part of our conference. It's mostly the hosts that prepare the best part for the very end, and so has been the case here. We have creme de la creme now, and we've invited experts from abroad to tell us about best practices from Europe. So we will hear this time not about the theory, but about the practical applications of hydrogen in the economy.
Our foreign speakers, and they will talk about lesson learned, how they prepare their hydrogen project and how they are going to teach us in order for us to be better prepared for hydrogen technology. First, I would like to introduce our first speaker, Mr. Guillermo Figuero from Spain. Mr. Guillermo jest inżynierem przemysłowym z Technicznej Szkoły.
Guillermo is a technical engineer from the Zaragoza Engineering School who works as business development manager for the development of new technologies, hydrogen technologies in Aragonia. He'll tell us about the Big Hit project. Guillermo.
Or better say, screen is yours.
Okay, so thank you very much. Thank you for the introduction. I'm glad to be here for this good practices in Europe panel. I'm going to share my screen. I hope everything goes fine. So you should be watching my screen right now. As you mentioned, I'm going to develop a little bit on let's say good practice in Europe for the Big Hit project. But first of all, some of you may already know Aragon Hydrogen Foundation, as we have been also participating in a couple of events in Poland in the last couple of years. So I remember very well being presenting the same project, Big Hit, in Pila 1.5 years ago. And I'm glad watching the impressive support and the job that you are currently developing for the Pomerania Hydrogen Valley. So Aragon Hydrogen Foundation is a research center located on the north of Spain, a private research center non-profit organization. We have a really good position in hydrogen Europe research and in the fuel cells engine hydrogen undertaking. We have developed more than 20 projects and we are still developing some of them during the last European framework, Horizon 2020. And we hope to continue with these international European collaborations with the Hydrogen Valleys as a flagship project for us. So let's talk a little bit about the Big Hit project. As a summary, the Big Hit project started in 2016. We are currently in the demonstration phase. We have been running all the demonstration pilots for the last 1.5 years. The launching event took place in May 29th. So we are currently collecting all the data from these pilot demonstrations, which is mainly, we can call it like the first pioneer experience in hydrogen valleys in Europe. And after this demonstration, the hydrogen valleys concept has been widespread throughout Europe. So the consortium is from about 12 partners, most of them coming from the Orkney Islands on the north of Scotland, but also British, Italian, and Aragonese partners from our region. And we have built it from scratch with the so-called method of the fourth helix. So we have the industry, we have the research and academia, we have also the public bodies, but we think that it's crucial to have also the community inside of the consortium of the project. We have been talking before in this event about the social aspects of the hydrogen projects. So the community, we think that it has been crucial to success in our project. So from where does it come from, the idea of the Big Hit project? So the Scottish inhabitants of the Orkney Islands have a really good amount of renewable sources, more than or about 100 megawatts of wind and tidal power, but they cannot profit of the whole renewable resource that they have, because they have a really bad connection with the British main island, only 13 megawatts of capacity of this grid, and so they have to stop their wind and tidal devices about 30%, 20% of the time. This means a loss of green energy, but also a loss of money for them, because mm, they are a really isolated community, and they are most of them managing by their own, by the community, these renewable sources. So together with the Scottish government and the Scottish Fuel Cells and Hydrogen Association, they came to us in 2015, and we prepared the proposal for the Fuel Cells and undertaking, and successfully we won it, and we are developing the project that you can see now in the screen. So we have two main points of production of hydrogen. Mm, 0.5 megawatts electrolyzer in the island of Ede, pen electrolyzer coming from ITM, the British entity, and also 1 megawatt electrolyzer, same technology, same provider in Sapiensay. We storage this hydrogen in 300 bar and distribute among the rest points of consumption through the islands in the ferries, but also this the storage is made in some trailers of an entity coming also from our region. This is also a really important milestone for us, because we are committed to develop industry also in our region. Which are the main consumption points? So we have several residential uses for micro cogeneration. We have also a demonstration pilot in a school to stay really close to the community and really close to the society. We have also 75 kilowatts cold ironing and grid service to the ships that are staying in the harbor. We have also a small fleet of vehicles, Renault Kangoo. These are batteries, electric batteries, rates extended with hydrogen in the main island in Kirkwall. So as I have said before, we are currently in the demonstration phase. So we have started to see which are the local and wider impacts. Of course, this is the first pilot project taking place in Europe. So awareness, visibility, and so on and so forth is crucial. We are also validating business and models for the integration of these renewable sources locally, but also in other in other locations. And we are helping and supporting to overcome some grid constraints and reduce the curtailment. This means generate more money and more local business for the community. And also we are boosting local economy through the local skills and the upskilling of qualified jobs inside of the inhabitants. But we are glad that we have been included in the panel of good practices in Europe, because this means that we are doing some things in a good manner, but we are also committing some mistakes, because we are learning by doing. But hopefully we can publicize these lessons learned to other consortiums, to other ideas, to other regions, to not commit the same mistakes as us. So now that we have been working on this project during the last 4 years, we know that the complexity of the deployment of hydrogen across the entire value chain is a paramount. It has a paramount importance for us. With the logistics, RCS challenges, it has been really difficult to be able to transport and to distribute the hydrogen inside of the trailers, but also inside of the conventional ferry lines in among and through the different islands. Is also crucial to don't overpromise in the preparation phase of the project, because finally private and public co-funding needs to be allocated somehow. And it has been also difficult to find local people that can work with these hydrogen devices. They need some local training and upskilling, and it has been difficult in an isolated territory as the Orkney Islands. And but finally, we have this local community involvement. So this sounds quite good. Which are the next steps for the Big Hit project? Well, it's very clear that the Scottish Government and Orkney Council are supporting more hydrogen projects. We are reflecting some of them in the screen. It may sound ring the bell, the High Seas Free project that is taking place right now, in which they are developing one of the first ferries when working with hydrogen. But we are also doing a really extensive work on replication and cooperation with other European regions throughout several platforms, like a Hydrogen Valley platform, like the European Smart Specialization Hydrogen Valleys Partnership, but also throughout the Hydrogen Territories platform that we have just launched last week. And well, I'm going to talk later about this Hydrogen Territories platform. And we are also looking for the scale up of these hydrogen valleys and island projects. And we have several experiences coming in the next years. I will also talk a little bit about this later. Finally, next steps. Lessons learned are really important for us, and we want to replicate it in another projects and another regions. So apart from the Big Hit, not apart, but apart from the physical implementation and demonstration of the hydrogen technologies, we have created the Hydrogen Territories platform. This is an interregional platform that will help members and regions to understand how they need to replicate the Big Hit project concept for creating a local and or regional hydrogen-based economy in their locations. So we have created free tools. The first one is the website. You can see the link afterwards. We have created also a replicability tool, really easy to work on it because it has been created in an Excel form. And we are also developing several webinars and face-to-face meetings. You can find all this information on the website. And as I mentioned before, the Hydrogen Territories platform has just been launched in a webinar last week, in which almost 100 entities and regions were inside of the webinar, coming from more than 30 countries, not only in Europe but also in Japan, in Australia, and in America. So the awareness that we have reached, I think is quite good for us. How the Hydrogen Territories platform defines a hydrogen territory? Well, we need to touch all the value chain of hydrogen, not only focusing on one application, not only on heat, power, mobility industry, but on an integration of all of these applications. And the best issue here is that you have or you are going to start your project or your idea with a basis that is the lessons learned from our experience, and that we are focusing also here in the tool. It serves also for isolated and remote territories more than for hydrogen valleys concept that everybody is talking right now. So the main objectives, as I've mentioned before, I think is quite clear. is to ensure the replicability of the hydrogen pioneer experience and local hydrogen-based economy. Also to transfer all this knowledge through a network of regions, and also in the last step to deploy or to start deploying and demonstrating this local ecosystem in another locations. What do you have to do to become a hydrogen territory member? As I mentioned before, we are already several regions in the platform, but you need just to follow the instructions in the link that you can see in the screen, and of course we are glad to communicate and to have several conversations before becoming a member, because obviously you will have some homework, but you will have also some benefits. So the main role that we are looking for these territories is to have some benefits, to have access to some key project deliverables that we have already developed, also to have access to methodology and to practical considerations regarding logistics of transportation, because this is a crucial aspect for the good practice of the project. And we are also in the way of sharing some recommendations and methodology for project replication. So you have here the link for the Hydrogen Territories platform. In any case, you can also communicate with me or with the project coordinators, and you can find all the information there. And just a brief final comment on the hydrogen valleys concept. As I have mentioned before, BHIT is the first experience of hydrogen territory. We are calling it now hydrogen valleys, in not such as isolated territory as the Orkney Islands. So we are also working really close with the Northern Netherlands in the HIPEN project that has started just this last March, and that hopefully will take place during the next years. This hydrogen valley has a really higher impact than the big hit, because the scale is up to 10 times the ones that we are producing in the big hit project, because they are also allocating really strong efforts in their industries that are consuming really high amounts of hydrogen. So hopefully they will replicate in the big hit project there and not commit the same mistakes as us. We are also collaborating in the project that will start next January, also coming from the fuel cells engine undertaking, the last call that took place in April, and that has just been evaluated. It will take place in an island. It will take place in Mallorca, here in the Balearic Islands in Spain. And well, we have not a main role here, as you can imagine, not either in the Heaven project, but we are there for the replicability tasks, also for several transversal and cross-cutting activities that will support and that are even more important in these days. And I have also to mention, to have the overall scope of the hydrogen valleys concept of what is also moving out of these European calls. We have already seen in a previous speech before that the project development assistance has already started. So one case is taking place in Poland, and several cases are taking place throughout Europe. We are working there as of observer network, thanks to the experience that we have gained in Big Hit. We have been called for that role, and we are obviously very glad to help all the regions to overcome their barriers and to develop and demonstrate that they are looking for and really committed for hydrogen economy. We are also working for the next hydrogen call that is taking place and that will start in 2021 with the next European Framework Program, Horizon Europe. It will be called Clean Hydrogen for Europe, and so we have a main role in some of the roadmaps, but we have the leadership of the hydrogen valleys. We are also leading the technical committee regarding hydrogen valleys in Hydrogen Europe research. So as you can imagine, we are real close, are working. We are working really close with the European Commission for these hydrogen valleys territories and hydrogen valleys projects. So if you have any doubt, I think that you can have a really good partner here in Aragon Hydrogen Foundation for developing your idea and your project in creating a local and regional hydrogen-based economy. So thank you very much.
Thank you very much, and I am really surprised that your presentation really proves that your case, your project is a good example to be followed, and it is the best fit for our session, lessons learned, what we can say.
Yeah, that's true.
All questions I had prepared were answered by you, so sorry, I have no question. And now we want to move to another speaker, another subject. Very close link also with the sea, because we will talk about the Emden Seaport hydrogen project, and the presentation will be done by Mr. Andreas Hennel. Andreas Hennel jest kierownikiem projektu w Departamencie Systemów Dostaw Energii w firmie DBI Freiberg.
DBI Freiberg is the institute represented by Andreas Hennel. He has experience in process engineering for 9 years. He was subject Jan Hubka's team in the University of Technology in Gdańsk and speaks Polish somewhat.
Yes, hello. I'm very happy today to give this presentation and actually to present you the results of a project we just recently finished, which was called WASH to Emden. So it means hydrogen applications for the seaport of Emden. So I just switch to the full screen. Okay, so maybe at the beginning, few words about the institute which worked in this project. So I'm from the DBI Gastechnologisches Institut Freiberg, which actually is part of the DVGW, so the German Association of Gas and Water Industry. So we as institute, we are a research institute which actually looks for innovations for the DVGW and for all the members of the DVGW. And these innovations later are then provided to the market by the GUT, Gas- und Umwelttechnik, which is an engineering office. And so this is a good connection all the time to bring good innovation to the market. Also worthy to mention, we as GTE company, we are an associated partner of the Technical University and Mining Academy of Freiberg. So our research also is very strong connected with the education of students. So also as an offer, if Polish students, for example, for the bachelor or master thesis would like to come to us, we have all the time interesting topics, so they are warmly invited to come to our institute and do some research with us. What we are doing, so we are focusing on gas fuels, so from the exploitation of the gas, underground storage of the gas, and transport and also utilization of the gas. We are actually doing everything. We also have parts of the company which is a testing laboratory. So we are testing and certifying gas equipment. So just recently we got a certificate for the hydrogen ready label, so that we can prove equipment and say, yes, this equipment can be used for the hydrogen gas grid. And also we have a training center, so where firefighters, for example, can train on gas equipment for explosions and how to distinguish the fire. Okay, so this is introduction to the company. So next, the Rush to Emden project. So this project was initiated by the Niedersachsen ports, N-Ports, which actually is a seaport infrastructure company, which has several seaports and areas, and who were looking for solutions to reduce emissions in the seaport. And they ask the question how hydrogen can play a role in the transition to a green port. So we were several partners from engineering office, APH, Marico and Maritime Training Center, Titschka Gas, or gas industry, us, and also associated partners directly from the seaport and from the region, the EPAS, and also from the high school or University Emden, LER, University of Applied Science. So we have looked in this project on several aspects. So the first main important aspect is from where you are getting the hydrogen. So we looked at four pillars, actually. One was the generation of hydrogen by mains current. So we developed a tool where we are able to calculate the costs of production, which also considers different surcharges, fees, and taxes. The second path was the hydrogen generation directly by renewable energy sources. So how is it possible, or how much hydrogen actually you can produce by just wind power? The third question, which from today I saw it's also discussed, which is also interesting to look at, is the extraction from hydrogen from the natural gas grid. And the fourth one, maybe to import the hydrogen from Africa or from other countries. So as starting point, we just will have short look on the research area. So this is Emden. Emden is most western seaport of Germany. It's the 7th biggest seaport. Per year, around 6.2 million goods are shipped in the seaport. And as you can see, for the hydrogen infrastructure, it has a very good starting point. So you can see just in the area of the city of Emden, you have installed power of wind parks of 192 megawatts, photovoltaic 12 megawatts. This is just the industrial photovoltaic, so without counting home PV, so it would be a bit more. And in front on the coast, the offshore, you have around 4.9 gigawatt of installed power of wind energy. Also from the seaport, interesting is that in the western part, there's also from the North pipe, the gas distribution and pipe is coming, and you also have location of gas underground storage, caverns, which maybe in future can be used for hydrogen storage. So we have looked at different aspects. So we also calculated, for example, how much hydrogen actually you currently can produce by the curtailment, so that you are switching off the wind power farms because the demand is not so high as the production of energy. So you can see that yearly you can already produce over 1,000 tons of hydrogen just by using the curtailment. So important question all the time is also how much does it cost? So we actually developed a tool within the project where we can calculate for different conditions how much the hydrogen will actually cost. So this will help us then for the next step to decide which electrolyzer will build and how to continue with the whole project. So the main finding, actually, what you can see all the time, it's question of the scaling. So if you are jumping from a very small electrolyzer to above 1 megawatt, you can just decrease the costs from 25 to around 5 euros per kilogram of hydrogen. And also you can see for this both green lines, the upper one, this is energy produced just by electricity coming from the mains current, and the lower one, this is just electricity comes from directly from the wind parks. So you can see that already taxes and fees on the electricity are causing around 1/3 of the costs of your hydrogen for the production. So this is all the time very important point to think about how you can actually reduce the cost of your production, because in general for production of energy, of electricity from the wind park, you are now around 4 cents per kilowatt hour of production costs, and just by the taxes it's it's very hardly increased. The next interesting question is to inject hydrogen and also to extract the hydrogen from the gas grid. So if you are looking on the German market, the technical regulation by the DVGW, the GE260 and GE262 actually already now allow hydrogen content of 10 volume% in the gas grid. And I made some examples so you can see there are two possible gases in the German gas grid. So the L gas with a low calorific value and the H gas with a high calorific value. So you can see the frame, this is actually the limit of the gas group. So depending on the composition of the gas, you can see that, for example, for L gas here, already there's a possibility that you are still in this group. You can even 15% volume% of hydrogen inject into the gas grid, and you still would fulfill all the properties given in the regulations of the DVGW. However, in Germany, you don't find the gas which contains 10 volume% of hydrogen, because you also have all the time to think about critical gas users. So critical gas users are mainly filling stations for CNG cars. So these filling stations mostly compressing the natural gas from the gas grid and refill CNG cars. and they are limited to 2% of hydrogen. So already there is some problem, and also CHP, there are some limitations to the hydrogen content. So until actually you can inject and extract the hydrogen, you have to look actually on the gas properties, on the heating value, how it changes, and also on the tolerance of their hydrogen infrastructure, so that you can inject the hydrogen.
Andreas, I
Actually-
see that you used nearly all of your time, and you are in the middle of your presentation, so please speak
Okay.
up a little.
Okay, yeah. So another part of the project was we looked on the import of hydrogen. So you can see that importing nitrogen is still in some cases cheaper than producing it in Germany. So you have costs around 6 to 4 euros for importing green hydrogen, or between 4 and 2 euros per kilogram for importing blue hydrogen with CCS technology. Okay, so maybe now about the project and the most important thing about the presentation. So we have analyzed for Emden the demand of hydrogen and which actually vehicles and devices can be fueled by hydrogen. So here I just prepared some table with interesting numbers of devices which can be fueled by hydrogen, which were also considered for the introduction of the or the initiation of the hydrogen economy in Emden. So for Emden we made a survey and we polled all seaport companies and asked how many equipment you have, how many cars, how many vehicles, and what is actually your current energy demand. So we gathered actually a lot of data, and we know now very detailed where are the users, how many forklifts are in the seaport, how many cars, how many actually daily are they using on different kinds of fuels in the seaport. So you can actually see there's a very high demand on diesel and very high also on marine gasoline oil of or in the seaport.
I'll give you only 3 minutes more. So,
3 minutes more. Okay, yeah.
3 slides.
So we know very exactly how many vehicles are, and we then made a feasibility study how much hydrogen actually they need. So for this, we developed different kinds of scenarios where we looked a minimum transition to hydrogen, also a maximum scenario for the transition, and out of this we then were calculating how big the electrolyzer and the production costs are will be in future. And of course, not only for the seaport we have done this, we also have done for the whole city of Emden. So with this, I just will come to the end of the presentation. So the whole goal of this, or actually now we are in the process of preparing the pilot installation. So we already gathered companies based on the study we have here, and now we are asking them to commit actually to buy forklifts, to buy trucks, so that actually we can start the market, to activate the market in the region of Emden, to install or to start a hydrogen economy in the region. So with this, I'm at the end of the presentation. Unfortunately, it's a very short time, so you are very welcome to contact me if you have further questions. Also, we can discuss.
Thank you very much for your presentation. I think it's a really good example for our seaport, for Zarząd Portu Gdynia and Zarząd Portu Gdańsk. And now they know a good example how to approach the project, or even better, to know the company and institute who can help them to develop that project. By this, we want to move to another speaker. And now we will talk about the different kind of application and details about the new approach to electrolyzer, because mainly all electrolyzers we are talking about are proton exchange electrolyzers. Now company Enapter will talk about their development and their modular electrolyzer anionic exchange membrane electrolyzer. Presentation will be done by Jens Bischoff, który po ukończeniu studiów w dziedzinie polityki i ekonomii ukończył studia
Presentation will be done by Jan Bischoff, who
zarządzania zasobami.
graduated from the Management of Natural Resources faculty. Currently, he's manager for business development in the company Enapter.
Thank you very much for the introduction. It's a pleasure to be here today and to introduce to you our anion exchange membrane electrolyzer and what we are doing. So the first two presentations today were more related to bigger research projects and lighthouse projects, so to say. My presentation will be focused a bit more on introducing briefly our technology, and at the end also to show you some use cases where our electrolyzer technology has already been applied. And at the beginning, I would briefly emphasize what Enapter is doing. So Enapter as a company is really focused on the electrolyzer part. So we develop and manufacture the patented anion exchange membrane electrolyzer. And we are not a turnkey solution provider, so we provide our electrolyzer plus optional equipment which is needed for the electrolyzer to customers who use it by themselves, or to system integrators who will integrate it in a turnkey solution for their customers. So if you have such a diagram of a hydrogen system, you usually have for green hydrogen PV or wind energy as input and water. And after the electrolyzer, in most cases, you would have hydrogen storage and further equipment like a fuel cell or other equipment depending on the use. And we are really focused on the electrolyzer. But one other product we have is our energy management system, which I will briefly mention later as well. And in our energy management system, it's also possible to integrate third-party devices. So a few words regarding anion exchange membrane technology. As was already mentioned during the introduction, it is a unique technology for electrolysis, and it's proven and patented already. So Enapter was founded 3 years ago and took over the developments which were done by ACTA in Italy for around 10 years already before that. So one of the advantages of the anion exchange membrane technology is that no noble metals are required, and thus you have a low-cost stack. But at the same time, you have a great performance and high efficiency of the system, and a very simple balance of plant as well. And compared to, for example, PEM electrolyzers, the input water quality requirement is also not too stringent. So filtered tap water or rainwater can work for our electrolyzer as well. Basically, in a nutshell, our electrolyzer merges the advantages of low-cost alkaline electrolyzers and proton exchange membrane electrolyzers. So here you see our product. It's the electrolyzer EL2.1, and it produces half a cubic meter hydrogen per hour and has a very high efficiency. So you only need 4.8 kilowatt hours to produce 1 cubic meter of hydrogen. So roughly speaking, per day, one of our modules can give you a little bit more than 1 kilogram of hydrogen. And that will already be provided and produced by the electrolyzer at 35 bar, which is very interesting for applications where you want to further compress the hydrogen, because you can skip the first step in the compression. So what is the goal of Enapter? So our goal is to reduce the price of hydrogen, on-site produced green hydrogen, drastically. So we have the goal to reduce the capex cost of the electrolyzer to 1.5 euro per kilogram or less. So that's calculated over the lifetime of the electrolyzer. And in order to achieve this, we have to undergo massive scaling efforts. And I will show a few points of what we are doing here. So one important point is that we consider electrolyzers as a product and not as a project. So if you consider the economic history, you can see that nothing has achieved cost cutting potentials as massively mass-produced products. So we draw an analogy to the IT industry in the 1970s, 1980s. At that time, mainframe computers were still around, but there were big engineering projects, took up a lot of space, and step by step they were replaced by small modular computers and laptops later on. And one of the advantages of such smaller units is that you can easily produce them very quickly in a factory. And that's one of our, let's say, strategies. So rather than producing very big central electrolyzers, we have a modular electrolyzer which can be produced very quickly in a massive factory. And we are currently planning to build a new factory to further upscale our production, which will open in roughly 2 years production. Another point is, of course, that we constantly work on improving our technology. So on this slide, you can see how much we have, for example, reduced the size of our electrolyzers. So within just 3 years, we reduced the size from 10 units in a 19-inch rack to 7 units. We increased efficiency. We updated the firmware and integrated many more features. So I'm not going too much in detail here, but if you would like to have a look at that in detail, please feel free to contact me. So, and the modularity of our system also means that if you have a low consumption of hydrogen, you can just take 1 or 2 modules. But if you would like to have higher flow rates of hydrogen, you can integrate electrolyzers into a 19-inch rack. And here you see a configuration of 4 of our electrolyzers, a water tank module and a dryer to achieve higher hydrogen purity. And if you need even higher flow rates, you can just add 2 or 3 cabinets next to each other. And the next step in the modularity and scalability is our AEM cluster, which we are currently working on. It's a container-based design. In this container, we would still use our standard electrolyzer modules, and we would stack them together. And by that, in a 20-feet container, you could have around 60 to 72 electrolyzers and a production of up to 36 norm cubic meters per hour. The next step in scaling up production for us is to work on a container which we call the AEM multicore. So in this container, you can see there's a difference in what you see inside the container. So in this container, we are not going to stack electrolyzer modules, but electrolyzer stack modules only. So we will have a 1 or 2 central balance of plants. And by that, we will reduce the cost further for such an integrated system. So in a 40-feet container, we would have 1 megawatt electrolyzer, basically, which could provide you 450 kilograms per day of hydrogen. And one advantage here of the scalability and modularity is that you have many, many small modules which you can run very flexibly. So the software, as mentioned, it can integrate some other aspects like third-party devices, fuel cells, etc. To save some time, I will skip here the energy management system in detail. And I would like to use the last minutes of my presentation to give you some examples of use cases where our electrolyzer has been used already. So we have delivered our electrolyzer already to over 33 countries and to over 100 customers. And basically, we are not focused on a certain application. So we have applications in all different thinkable hydrogen application areas. So for example, we have different applications for refueling. So we have several customers who use our electrolyzer to produce hydrogen for hydrogen drones. We have also customers who integrated our electrolyzer into forklift refueling stations and other sort of refueling stations. A hot topic recently is also power to heat. So we have several demonstration projects where our electrolyzer is used to produce hydrogen for heating districts or heating bigger buildings. This here is an example from the Netherlands, where 8 of our electrolyzers are used to produce green hydrogen on site for heating building complex. There are also many different industrial applications where on-site production of hydrogen can be very cost advantage over delivered hydrogen. So we have already applications in the production of ammonia, glass industry, food industry, nitrogen purification, and some others. Power to gas is also a very hot topic. So many of the gas TSO are thinking about their business model in the future. They're researching how to integrate gas into the grid. We have several customers who used our electrolyzer for small-scale demonstration projects on how to test how to integrate and feed hydrogen into the gas grid. Residential applications is also becoming more and more popular. So here you see a demonstration project, the TCR house from Thailand, where our electrolyzer is used for 3 buildings to produce, to have autonomy over several days. But we have similar projects also in, for example, in Germany, in Munster, in the UK, in London. And it seems this is also very interesting for a lot of private people who want to increase their autonomy. If you think this a little bit bigger, then from a house perspective, you can go to a microgrid. And that's also an application where our electrolyzer is used already in many cases. So basically here, like in the Mafate Reunion Island project, hydrogen enables a solar microgrid, and the hybrid of batteries, hydrogen and solar provides a 5-day autonomy for this small village here. So thank you very much for your attention.
Thank you, Jan. You're perfect on time, exactly as we agreed. Very interesting presentation and very interesting solution. And I start to think about my home and maybe to install such a small electrolyzer at my home in future when I buy the hydrogen car. But anyway, your presentation also a good introduction to our last speaker, because on one of your slides we have seen the equipment from the Fronius company, and our next speaker comes from the Fronius, Mr. Gregor Blanca, who is the który jest kierownikiem sprzedaży w jednostce biznesowej.
The sales head of the business unit Fronius International, responsible for solar energy. He's responsible for developing projects concerning adjusting and tailor-making Salt Hub solutions.
We now talk about the solar solution, green hydrogen. This is what is the direction shown by European Commission. Gregor, the screen is yours.
Dzień dobry. Ja
Dzień
też
dobry.
mówię trochę po polsku, niestety nie bardzo dobrze.
I do speak Polish somewhat, unfortunately not very good. I prefer English.
So thank you very much for the organization of this conference. My name is Gregor Blanca. I'm from Fronius, and Fronius is an international producer, and our headquarters is in Austria. So basically we produce welding robots, solar electronics, and battery charging systems for the industry. But since almost 20 years, we now do research and development in the hydrogen sector. And so that's why I'm very happy that we can present it here in this conference. And I'm going to share my screen now. So in times of Corona and COVID-19, we still want to stay in touch with our customers closely and to present our products. And that's why we developed an interactive web page, which is like a virtual fair. And you can go directly by typing virtual-fair.fronius.com/en for English, or DE for German, on this virtual fair. Or you can also go on our website, fronius.com, follow solar energy, and you will find your way to our virtual fair. And here you can, I will make it a little bit bigger. Here you can take a look around and inform yourself about all our products, such as the new inverter, photovoltaic, a lot of information, a lot of videos, and you can get in touch with us directly. So now let's take a closer look on our hydrogen product. It's called SolHub. You have to understand it as a ready-to-use system. It's a local hub for producing hydrogen locally, for storing hydrogen locally, and using hydrogen. Most of all for refueling hydrogen vehicles. Optionally, it's also possible to integrate a fuel cell for reconversion of electricity. So now I want to show you a little bit more about the components. This SolHub actually is in Austria, in Upper Austria, close to Wels, and you are invited to visit it. On the right-hand side, you see a photovoltaic system. This one has about 6 kilowatt peak. To be honest, this is a little bit too small for this electrolyzer, for this system, but for us, it's standing symbolically that we just want to use green energy. On site, we have a bigger, in the background, a bigger PV system with about 300 kilowatt peak. So the energy flows to this black container. In here, basically are the electrolyzers. Here we produce the hydrogen and we compress it. Afterwards, we go to the storage on the left-hand side. And as you all know, you can store hydrogen for a long period of time. If you want to use it, it flows to the dispenser on the right-hand side. And here you can use it to refuel cars. And I'm going to show a short video. What you see here is the refueling of commercial vehicles, but also of private cars. That means that we can provide SolHub with in a 350 bar version, but also in a 7.5 bar version, and it depends on your needs completely. And what you also see is that refueling a hydrogen car is as easy as refueling, let's say, a diesel car, and it's also as quick. It just needs 3 to 7 minutes. It depends on the car. So now we can go directly in the container to take a closer look. What you see here is that there's a lot of free space. Why is that so? Because SolHub is designed as a modular system. That means, for instance, we can put in this container between 1 and 4 electrolyzers. And in this case, we have 2 electrolyzers. On the left-hand side here, you see the water treatment. So we just use normal tap water. The water comes in the electrolyzer, and afterwards in the background you see the compressor. And we compress the hydrogen to the needed pressure level. Just for information, at the moment, 1 electrolyzer can produce up to 13 kilogram hydrogen per day. That means with 4 electrolyzers in 1 container, we can produce at maximum 50 kilograms a day. The next version, which will be available at the end of next year, we will be able to produce 50 kilograms per electrolyzer. And now I go outside of the container again and move to the storage, which is on the left-hand side. Yes, what we see, of course, is that hydrogen today is stored in, let's say, normal gas bottles. Again, here, the same situation as in the container itself. It depends completely on the customer's need, how many bottles he gets, how big they are, which pressure level we can provide. When we think about a seasonal storage of hydrogen, means from summer to winter, for instance, then normally we need not such a big pressure. I would say 30 bar is enough, and then we use bigger bottles. When we think about commercial vehicles, we need around 400 bars, so that because they run by 350 bars, and private cars, of course, need more pressure, so then you need 700 bars or a little bit more. Yes, so I really invite you to take a look at our virtual fair, and maybe a last information about SolHub. SolHub, as I said before, is a modular system. So it depends how many hydrogen you want to produce. Then we can put more or less electrolyzers in the container, or how much you need to store. Or it's also possible, of course, to have 1, 2, or 3 dispensers, and with different pressure. And in the basic version, in the smallest version, the SolHub costs around 670 to 700,000 euro. And this includes the electrolyzer, which produces 13 kilograms a day. Okay, so thank you very much for your attention, and I give back to the moderation.
Thank you very much. It was really last but very interesting presentation, and I have to say that for me the last session was very, very interesting, and really lesson learned also by me. We have some questions from audience, but they are very technical. For example, I will read you one. It's not to you, but to Mr. Jens. what is the nominal current density for electrodes and operational voltage from one cell. But I think we know the name of the participants, and you can just answer very quickly, but there are other technical questions, and we will contact you by email. But please, if you can answer it, that would be fine. What is the nominal current density for it?
Detailed technical questions could be addressed later by email as well, but the specific information asked in this case we would not share. Please understand this.
So thank you very much. It is the last presentation, the last part of our conference.
Wir befinden uns hier vor unserem neuesten Produkt, dem Fronius Solhub. Das ist ein dezentraler Knotenpunkt für Sonnenenergie. Hier im Solhub wird Sonnenenergie mittels Elektrolyse in Wasserstoff verwandelt. Der Wasserstoff kann dann für wasserstoffbetriebene Fahrzeuge abgetankt werden oder auch zum Beispiel im Winter rückverstromt werden und dann wieder in die Netze eingespeist werden. Dies ermöglicht Energiegemeinschaftsanlagen, Kommunen, Unternehmen, Logistikern, aber auch Landwirten, ihre eigene Sonnenenergie zur Erzeugung von Wasserstoff zu benutzen und mit diesem Wasserstoff emissionsfreie Logistik herzustellen.
From the very beginning, we feel the urge to move and discover the world. We walk, ride, drive, and travel. We're always on the move to learn, work, relax, keep fit, explore, and of course, to meet each other. When we can't, we confine our very nature. We depend on mobility for ourselves and for moving all those things we need and want in life. We've always been very ingenious when it comes to getting ahead faster, more safely, more reliably, and with greater comfort. Today, we need new solutions for new challenges. This is what drives us. This is why we're so passionate about mobility and always go that extra mile to move beyond what's possible today. We are pioneers in transportation, helping our customers keep the world in motion. As their trusted partner, we create ways to move people sustainably and seamlessly, from the first mile to the last. This is our vision. This is what we're moving toward and beyond.